Hello, everyone, and thank you for joining our third session of I Didn't Know ServiceNow Did That, and today's topic on tag-based alert correlation. My name is Corey McKay, and I am joined by my colleagues Emily Walker, Matt Morris, Carlos Peterson, and Robin Cincinnati. We are going to kick things off by reviewing ServiceNow's platform from a high level for those that aren't as familiar, before we dive deeper into the functionality and demonstration of tag-based alert correlation. Please feel free to use the chat for any questions you might have, and we will be happy to answer them at the end of the call. Please remember that this presentation may contain forward-looking statements that reflect the current beliefs of ServiceNow and are based on current information available. These forward-looking statements should not be relied on to make purchasing decisions. The challenge that most modern enterprises face is that work is unstructured and it's happening within disparate systems of record. These departments have their own data model and systems of record that are stored on various legacy technologies. But work happens in silos, lowering productivity and user experience because individually, they don't support how work flows across your enterprise. And replacing these core systems is an expensive and lengthy process. Our Now platform excels at digitizing workflows throughout a company or across several functions in unified experience. That's why we call the Now platform the platform of platforms for business solutions and all workflows. Our unique differentiation is providing you with one platform, which shares one data model, one architecture, as well as many built-in powerful capabilities, such as the ability to easily build cross-enterprise workflows, a single CMDB, machine learning, AI and predictive analytics, native mobile and conversational interfaces, and a set of no-code and low-code development tools for anyone to build their own apps. ServiceNow connects organizations, creating a seamless enterprise system of action that integrates silos and systems, enables great employee and customer experiences, and increases business agility and unlocks productivity. On top of our platform, we offer the best-in-class out-of-the-box workflows for IT, employees, customers, and creators that orchestrate work across the enterprise and are unique to each industry. These solutions were developed organically, 100% native to our platform, and we offer the same exact platform for you to build your own no-code and low-code apps to deliver enterprise workflows and other business solutions. Our partners are also building apps on the Now platform, providing an even greater selection of ready-to-use workflows for your business. And lastly, all of your existing omni-channel experiences will have out-of-the-box integrations into ServiceNow from mobile and web to conventional and collaboration and productivity tools such as Slack or Microsoft Teams. So you can deliver great experiences to your employees, customers, and partners through interfaces that they love. Today, we'll be focusing on the IT operations management workflows, also called ITOM. Diving deeper into the capabilities, today we'll be focusing on event management within ITOM. With event management, customers can monitor the health of services and infrastructure using a single management console and respond appropriately to any issue that arises. Event management provides intelligent event and alert analysis to ensure continuity of your services. An alert is a notification for selected events that are considered to be important and require attention. Event management generates alerts based on event rules. Alerts are grouped either automatically or manually into rule-based, automated, manual, CMDB, or text alert groups. Grouping alerts enables you to narrow down problems by focusing on the primary alerts in a correlated group. Today, we'll be focusing on tag-based alert correlation. I'll pass things over to Emily Walker, one of our solutions consultants, to explain more about this new capability.
Thanks, Corey. Hi, everyone. Thank you for joining today. My name is Emily Walker. I'm a solutions consultant specializing in the ITOM platform. So today I'll spend a little bit of time going over exactly what this new capability entails and how it works, and then I'll pass it over to Matt and Carlos for the demo portion. So if you have any questions during these next couple of slides, please feel free to drop them in the chat and we'll do our best to answer them. So let's get started. The tag-based alert clustering engine was launched in the ServiceNow Store just about a month ago on the Quebec release. This app is also compatible with the Rome release, which was made available as of September 16th. You can find this in the ServiceNow Store by going to store.servicenow.com and then in the search bar, typing in tag-based alert clustering. Here you can also find the release notes. So why did we create a tag-based alert clustering engine application? Well, this app was created because we really wanted to build something that provided value right out of the gate for our customers. We know that modern IT DevOps teams need flexibility and quick time to value. The tag-based alert clustering engine app is a zero-code method that simplifies alert grouping and performs alert correlation without the need for a fully built-out CMDB. The app also allows for the event management admin to define meaningful tags which are sourced from alerts and CI information. The admin is able to define whether these tags should have an exact match or a fuzzy logic, meaning that the tags are text similar but not exact. This enables the system to automatically cluster different alerts with a configurable time window. And this happens without relying on the topology information or long learning cycles. You can enable alert clustering immediately from activation, and it works in parallel with your existing ServiceNow alert correlation algorithms. So why is this all important and amazing? Well, customers that are just starting to build out their CMDB or have yet to build out their CMDB or have no intention of building out their CMDB, they can realize the value of tag-based alert correlation from the get-go. We wanted an easy way to deliver deterministic, no-code, valuable alert correlation on day zero without needing a fully built out CMDB. We also wanted to derive the ongoing value from ITOM Health. Additionally, this new app helps to drive positive outcomes in a more modern, agile, cloud-native environment. One thing to note here is that this application is available on our store and free to customers licensed for any SKU that entitles event management. All right, so I'm going to go into how this all works. Tag-based alert clustering engine consists of two items: alert clustering tags and alert clustering definition. So first, let's talk about tags. Tags indicate the criteria for which must be met for alerts to form a group. They can be used in one or more definitions, and tags may be derived from a field on an alert table. They may also be derived from a key in the JSON of an alert's additional information by specifying the key to be used, or they may be derived from an attribute of the alert CI. Once we have the alerts, the method to determine whether two alerts tags match can either be exact or fuzzy. So exact meaning that the values for the tags must be a perfect match for those two alerts to be grouped. Fuzzy meaning that the values for the tags must be at or above the user-defined similarity threshold to be grouped. So from there, you bind the alert clustering tags with an alert clustering definition. So let's spend just a minute talking about the definition. Definitions allow for a user to set one or more of the clustering tags that will be used together to group alerts based upon similar values. You can create a filter to indicate that only alerts matching the definition's filter are compared with existing alerts. If the filtered alerts match that exist in the system based on the definition's alert clustering tags, they form an alert group. If alerts match multiple definitions, then the order of definitions would be evaluated from low to high. And finally, definitions really allow for a user to set a time frame for the alert clustering when tags match. So this slide gives us a quick overview of the event lifecycle, and it really explains where this new clustering engine app fits into the observability and AIOps story on the Now platform and the actionable incidents it can help with. So first, events are coming in, and these are typically raw notifications of an issue from your various monitoring tools with inherent information or from our agent client collector. So once an event matches an event rule, it gets processed into an alert by the system. And from there, the alerts can be grouped by one or several methods. Previously existing methods grouped alerts based on bound CI details, natural language processing, or learned patterns. But with this new tag-based alert clustering app, you now have a robust alert grouping method, which is transparent, deterministic, and easy to use. It's also one of the only methods that can be based solely on alert content, even if a CI is not bound. So this really allows customers to reduce that noise from multiple alerts into one actionable ticket, reducing mean time to XYZ, detect, failure, resolve, and then get down to actionable incidents and save time and effort in the process. That wraps up my portion. Matt, I'll pass it over to you for our demo.
Thanks, Emily and Corey. So I'm going to run through an example of how this can work in a real situation. Just want to confirm real quick that everybody can see the service map. Okay, so this is a service map that was actually created by our cloud native operations application. If you haven't seen that yet, it's in the innovation lab. It gives you a one-click way to run a bash script that will give you full visibility into your Kubernetes services and also bring events from Kubernetes. So this is just a quick plug for that app and how useful it can be to help you quickly build a service map of your Kubernetes services without having to do any other kind of discovery or scrape the cluster or get any kind of credentials. into Kubernetes. So we've built this service map. We can see that we've got several different issues that are lighting up the map here. And we want to see how we can use tag-based alert clustering, the new app that we have, to be able to cluster these into one issue. So as they flowed in, we actually ended up with 3 different alerts that needed to be tackled. There were 4 separate events that came in order, and the first one was that Log Analytics noticed there was an issue where intrinsic latency was being noticed at a lower level in the application, a Redis box. And then we had an issue that came in and said, hey, there's a liveness issue where the health is being affected at the cluster level of our cart service. And then finally, the cart service said, hey, reachability on this service at its entry point is not good enough. It's only being reached like half the time. And finally, we saw this last one where we said, you know, the boutique entry point for the application is taking too long to respond. So we had those 4 different alerts that came in. 2 of them got grouped because they were bound to CIs that were related in CMDB, thanks to the Cloud Native Operations app. But because of the way that the alerting tools are feeding in this case, Prometheus, for example, the way that it fed in the node for our boutique entry point, that was not something that was able to bind to a CI. And so we need another way to be able to group on these kinds of issues so that we can have one actionable set of alerts rather than needing to address them separately, as well as getting separate incidents and so on and so forth. So we want to be able to use just the contents of the alert payload itself to be able to do the grouping. And we can look here at the Prometheus example, what tags were fed in additional information in this JSON object. We can see that we have 3 that were actually provided: app service, environment, and region. And so what I want to do is I want to quickly create a definition for an alert correlation definition that would combine both the app service tag and the environment tag. And wherever there's an exact match on alerts within a certain amount of time, that it will pull them together into one group for us. And then we'll run that back through again, the same scenario. So we have our tag-based alert clustering definitions, which we don't have one yet. So we'll go ahead and create one, and we can call this app service and environment. And I'm just going to define some filter criteria for when I want this to apply. I'm going to say additional information needs to contain app service, and additional information needs to contain environment. And then I'm going to set my time frame to 30 minutes for this. You can set that to be whatever time frame you're comfortable with for the scenario that you're playing out. But we need to add a couple of tags to this now based on Emily's description, right? These can be based on a couple of different sources of information. It could be from an actual alert field that's on the alert table. It could be from a key that's in the JSON object that's inside of additional information, or it could be a field that's on the alerts CI if the CI is bound. We're going to focus, instead of any of the others, we're going to focus on additional information today. So we're going to use the key of app service. And match method, again, it can either be an exact match or it can be fuzzy, which is where we set a threshold where we say if it's 90% similar or 80% similar or whatever, then group it. But in this case, I want an exact match. That's what I'm expecting here. So now that I've added that one, I'll add another one quickly for environment. And we'll do the same thing. Our source, again, will be the additional info. The key we want to use is environment. Match method, I'm going to go with exact again and submit that. And now we'll go back to our filtered list that was showing us our Kubernetes alerts. And I'm going to close out the alerts that we had before. And I'm going to run a scenario again that's going to fire all those alerts back in. So we'll close those out. You'll see them momentarily disappear. And before we do that, we want to save our definition that we just made and make sure that it's showing as active. So we see now we have this one that is active, and we'll run our scenario again. So now as those run, we'll see the old ones fall off, and we'll see some new ones start to come in. So again, one of the benefits here is that we can easily get to grouped alerts where we might not have had that opportunity before. We have several other methods of grouping that can happen on the platform, but for those that are more machine learning based, they're going to be leveraging different types of information from, for example, the CI that's bound to an alert. So if we want to be able to see, grouping that's being done just on the alert payload itself, the best thing that we can do is to have, an option like the alert, the alert clustering engine that we have here with this new app. So at this point, we have 4 new alerts that have come in. They all got grouped into this one rules-based alert. We can see that we have our impacted services getting attached based on the alerts that did have CIs bound to them that put them in the context of a service, like our boutique service and our broader Kubernetes environment service that we have. And we can see the 4 alerts that are in the group. So again, running through that scenario of the 4 alerts that came from actually 4 different sources. Log Analytics initially identified the issue. Then the ITOM agent noticed an issue from the Kubernetes side. And then WeaveScope noticed service was unreachable. And finally, Prometheus was looking at the endpoint. Finally, we get the probable root cause being highlighted as the first alert that came in, which points us back down to the Redis service. So within a matter of less than a minute, I'd say, we were able to create easy reusable logic that allows us to take advantage of data that's in our alert payload to get to our desired outcome of one addressable issue. And now I'm going to pass it over to Carlos to show us a little bit of some different visualizations that we can use to make the most of the ServiceNow platform.
Today there are some various experiences, for different personas that work in different, preferred methods. We have a cell phone, right? So meaning that we have our application from an event management perspective. I can look at, for example, that same boutique application. I can understand the attributes, how important it is to drive workflow, and even drill into the alerts, the grouped alerts, and do some sort of action like take assignment or things of that sort. Well, that's been there. Also, we know from a targeted notification, we understand that whether or not certain personas kind of work out of Teams, or in this case, I'm showing Slack. The idea is that we can get a summary of the grouped or correlated or clustered alert and even take action to move the process forward. And that is something, the power of the workflow engine, which we've had. And then obviously what Matt had shown is, maybe to a more centralized IT NOC view of the service maps themselves, being able to drill into the telemetry and take action, orchestrate remediation, obviously to restore availability as quickly as possible. Okay, those are all existing experiences. Now, what about the platform engineers, the cloud ops, the site reliability engineers, or even L2, L3 SMEs? Well, this is where we start to bring the insights from the ServiceNow platform out to the environment that they work in. So what you're looking at is Grafana. So if your company does on the digital side, or the PaaS, the Kubernetes engineers, site reliability engineers, if they're using today Grafana, we have a custom plugin that allows those users to get the insights. The data never leaves ServiceNow. It's just queried using REST APIs to give them the context, the service context, things that they may not necessarily see. And maybe that persona also, they're not spending their time in the ServiceNow platform. So again, let's bring these insights and bring it out to the environment that they typically work in. So let's take a look at, this is just one. We have a whole bunch of different dashboards that cover essentially the wide range of applications on from an ITOM and even extended outside of ITOM to give relevant information for those personas. So in this case, we're looking at that same issue that Matt was discussing. And we have all kinds of information about the infrastructure, the Kubernetes, and it's not limited to Kubernetes again. But in this case, we can also give some information about the attributes of that application service. How important is it? Who are the app owners? In fact, we can also start to indicate what are the, is there an outage? Maybe the major incident team or the site reliability engineer has determined there is business impact. Maybe something from the CI/CD pipeline is deployed to a microservice, and it's caused an issue where the users can't access, business is impacted. So being able to reflect that very easily becomes important. So we all have the context, at least looking through the optics of a specific persona. What you're looking at here is actually all data from the ServiceNow platform. So we're getting metrics that are being collected by our agent client collector, but this could be also Grafana plugins that you're already using, maybe from Prometheus, that can be mixed and matched to make those insights really come alive. And now what you're seeing here is this is the application service, right? This is what from our agent client collector or the ServiceNow service mapping or even discovery, the power of the platform, where we can provide, an understanding of the various CI classes, but again, give it in the context of either infrastructure or even from a service perspective. We see on the right, just to kind of continue with this experience, we have key metrics from the nodes, right? The infrastructure that's supporting Kubernetes. We have the alerts, and if needed, whether it's from an incident or even an alert, if we need to drive that persona back to the ServiceNow platform in context because they're not necessarily familiar with navigating, we can do that just by having a link here that will, again, give them context back into the platform if there's some action that needs to be performed on the ServiceNow platform. Also, whether or not, how are things getting grouped? And we can even drill down and provide some insights. Exactly, there might be those personas. Exactly how did ServiceNow cluster these related alerts? We provide the technique, whether it's ML-based, alert tag-based, or other. And what is the primary alert that's being actioned on, and then all the secondary alerts, and if there were any related changes as well. So all of that great, valuable insights at the fingertips of the personas that otherwise would only have a really narrow view using kind of their typical data, whether that's coming from maybe a Prometheus or they're using the cloud tools from the cloud provider themselves. Okay, let's keep going here. What we also see are some key metrics and baselines from a Kubernetes service, which again, we can start to look at changing the time frame. And again, this is all the valuable data that we can now start to bring to life for that particular persona. So they can start to see where outside of the baseline, whether it's telemetry, we're looking at actionable alerts, or even for some of you who are familiar with our health log analytics, being able to not only show those clustered anomalies, but even expose the, what I would say, in this case, we had an issue with the cart service, and be able to expose the logs themselves all from Grafana, and then very quickly be able to drill down into specific logs very easily, the same capability that you can do from the operator workspace. But again, provide those insights, bring them out to the environment that they typically work in. So this is going to wrap up. I know I'm short on time. If you're interested, please reach out to us. We have this plugin that we'd love to get some feedback. We cover everything from event management. We can drill down into specific CIs. If you have the agent client collector, that we can expose all the telemetry, inventory data, as well as even running software, especially if I very quickly as a L2, L3, maybe a platform engineer, are there specific, is there a software that's running? Are there running processes that can help me triage? Is there a rogue process potentially that I want to check? So having all that information that is typically kept in ServiceNow, bring that in just a few clicks in context to help accelerate restoration service, as well as really align to make those personas a little more productive with our added context, our added service context as well. So that's just a quick experience from the Grafana perspective. I'm going to pass it back.
Thanks, everybody. Great job. Yeah, so we wanted to save a couple of minutes for Q&A live. I saw a few things in the Q&A earlier. I just wanted to review with everybody. One of the folks asked, how low code is it to define the alert tag definitions, heavy regex? And I think we answered that in the demonstration, where it's no code form-based, as you would imagine it to be for ServiceNow. Another question was around, is this feature limited to cloud architecture, or can I use it on-premise as well? And the answer is yes. So it's for any information that's coming in from your monitoring sources, right? So we can grab that information, as Emily and Matt had mentioned earlier, within the fields of the alerts, as well as the additional info that comes in. And let's see, lastly, one question came in about, can I use this feature for tags discovered from AWS or Azure? And that answer is yes as well. We can pull them in from the additional info, as well as anything else. Any other comments from the group? I know we're at time.
So the tag, and Matt, maybe we're, so the tags from the discovered CIs, obviously that today that's, version 1, that's not there. Version 2, which is out, I believe, Matt, correct me if I'm wrong, in the November timeframe. I can't give you a specific date. That's where we're going to be able to start leveraging more and more data from the platform. So again, discovering a PAS EC2 with any kind of labels or tags, those now become another option to start using to do this very deterministic clustering. So great question.
Yep. Thanks, and we're out of time for today, but please join us on November 11th. We have our 4th session for I Didn't Know ServiceNow Did That coming up, and it's going to be all around. Agent-based automation. So stay tuned, and we'll see you then. Take care.
Thanks, everyone. Everybody.
Thank you. Bye.